Hey guys, Happy New Year. So I'm going to do a little bit of a presentation on the current state of not just what I'm working on, but also the MCP ecosystem as it is today. So I'll do a little walkthrough of a bit of the protocol and the exciting things that it enables, which I hope more start to adopt. Because right now we got this weird situation where the specification is growing and advancing far faster than the actual MCP clients and also servers. And a lot of them are not utilizing to its fullest capabilities. And the cool thing is, once we start utilizing it to its fullest capabilities, a lot of magic can happen. So just over the top of from the beginning, everyone knows MCPs is running tools and everything like that. And at the base form, yeah, it can run tools and enable you to hook in different servers and applications that run locally so that your LLM can use it, which is, cool. But there's actually a lot more that can happen. So for example, there's client features like sampling. So sampling basically means that if there's an MCP that needs to have LLM generation ran on something, instead of the MCP having a model at the edge to be able to run it, it instead sends what it wants to be ran by the LLM, and then the person's LLM with their own keys and service and everything that they're using runs it for the MCP server, which is quite cool. So you don't really necessarily have to have an LLM on the edge. It'll just be the client's LLM that'll be running that themselves, or you can have it on the edge. There's really impressive research coming out since the beginning of this year. One of them was someone found a way to reduce the size of an LLM by up to 90% with no loss, allegedly. I do want to look at that, but that's relevant for this. So that's sampling in a nutshell. Really great to have. Now, elicitation as a client feature is also incredibly important. And it's not just incredibly important for what we're doing, but it's also important for the orchestrator. So what the elicitation essentially allows to happen is that when you're using an LLM and an MCP, and it says you want to run this command once, or do you want to run it always, or do you want to deny it? Those sorts of basic elicitations do exist already, but they can be a lot more in depth. For example, I need to get the API key from this user so I can run this command on this website. Right? And the client should be able to handle that without ever exposing that to the LLM, because anything that goes to an LLM, especially if it's like ChatGPT or anything else like that, are considered live. And there's people that have had their API keys caught in flight, which is really surprising to me, to services like ChatGPT. But elicitation allows you to ask any sensitive information, or little things, for example, choose your favorite color, which describes it as an enum with red, green, or blue. And then the client basically can display that in ever which way that it wants. And these could be human in the loop, or it could be AI in the loop, either or. But it's got a bunch of nice descriptions for here's one for string, here's one for number, and all these primitives to enable you to essentially pass over information to an MCP server and securely over OAuth or however other service or security mechanism that it's using. So that's elicitation, very powerful. It's hard to find MCPs that are using this today. Some do exist, but they're not really fully using it per se. But for us, this is really important. So for example, if a service needs to know where the person lives, for example, or if the service wants to know or wants to spend some balance, or if the service wants to know how much balance a person has, or any of these other this information that is expected in a cryptocurrency world, you'd be able to ask us through elicitations. Really difficult to implement on the server side, client side as well, but very powerful nonetheless. Then for server features, prompts are basically like your slash commands. And for the orchestrator, this was a tough challenge to solve, because if there's like 10,000 MCP servers that are connected to it, and they all have their slash commands, and let's say there's like 3 that are for Git, a lot of them are going to have, like, you know, the same slash commands. So I had to namespace them a bit to be able to get them out. So for example, it'd be like GitLab semicolon and then the command, or and the likes. But prompts right now are in the orchestrator. So if an MCP server has a slash command, it will show it on the client side. And as for resources, this has been around for a bit. So you're able to hand over resources, for example, not just like text, but also images and any other types of files to the client. And that's essentially what resources is doing. Tools, this is what everyone thinks of MCPs are, and this is just your general run-of-the-mill tool usage. So I don't really need to explain it too much. And another great feature of the latest MCP spec is that it no longer has to be blocked. So if an LLM is calling a tool, usually it waits for its response in order to continue. But now it's actually possible to have this completely unblocking. So the LLM will just send off, like, you know, a bunch of tool commands, and then it'll just wait. Or it won't wait for a response, but the service will tell the client saying, hey, this is now done. And then it's able to actually communicate to the user of, like, you know, what just completed. So it's cool because in this interaction, when you're talking to the LLM, right now it waits for everything. It can take quite a bit of time for it to run through some of the tools, especially if it's trying to find a tool and it's trying different tools to see, like, you know, if results are good or not. Like maybe it's trying to search for information on Wikipedia, Google search, Kaggle search, and everything else. These all can take time for it to poke through. But the cool thing is that it'll send all these out and it'll immediately return to the user and basically say something along the lines of, yeah, I'm just running through those searches right now to find the information that you wanted. Just, like, you know, give me a second, and the user can respond back to it. But once it gets a response, it gets kicked and goes, all right, here's a response from Kaggle and Google. And it goes, oh, I just got my responses from Google and Kaggle. This is, like, you know, what I found, and here's the information. So it's able to be pushed to give another message back to the user whenever those start to complete. So this is good for long, you know, extended tasks that can take up to an hour to complete, or a day to complete, or maybe they're time-based. Where let's say, like in our world, if someone's executing a trade, this trade could be sent off and it could be stuck, like, you know, and pending until it's executed. But when it is executed, it can be flagged as being complete. And then at that point, the LLM can notify the user like a day or 2 or 3 or 4 or a week later, saying, hey, by the way, you know, these trades just completed. So it's able to be kicked in information when things happen. So that's pretty exciting. So this world of MCPs that we're going towards is really exciting, but the problem is, as I was saying before, is that the protocol specification is miles ahead than the rest of the community. So if we look at client support, and the funny thing is there actually should be more tabs on here. There isn't a lot of clients that fully support everything. So there basically is only Claude Code and Claude Desktop Ed, and that's about it. And it doesn't even do sampling yet. And there's actually more that it doesn't do as part of this list. But if you look at it, every other client, they're only pretty much handling tool support. That's basically it. Not only that, a lot of the libraries for MCP, including the Rust one, including the one written in Python and everything else, are also a little bit behind the specification. They're almost there. The Rust one just enabled metadata, which is big for us. And the metadata allows us to actually describe where, for example, type information. So when we're hooking up MCP to MCP to do this orchestration, and I'll explain the orchestration first, just as a recap. How the orchestration, right now, the world is primarily dominated by LLM orchestration. So the LLM will figure out what tool it needs to call, and it will call them in the sequence that it thinks matters. And it will be able to transmute the information to feed it into another tool, and so on and so forth. This is lengthy, it's timely, and it's expensive. For our orchestration, instead, we're using symbolic reasoning, which is good old-fashioned AI, as we call it. But it works a lot in the same way, but a lot more explicit. So the cool thing is that you're able to define like what you want as a result and give that to the orchestrator in plain English with a data object of like, what you want it to be. And it should be able to figure out what tools it needs to call to fulfill that request. But for us to know what tool works with another tool, we have to know what the types are. So if something takes in, let's say, for example, in the cryptocurrency world, Unicity as a value, right? We don't want that being put into something that takes in Bitcoin as a value. We want that to be Unicity as a value. So the metadata field that was just added finally enables us to explicitly put this typed information so that our orchestrator knows that this hooks into that, and that hooks into this, and that hooks into that. So it's able to do all this orchestration on its own. And it's lightning fast. There is no LLM that is like generating all these data objects or anything else like that. It's a lot more explicit, and it's able to fulfill things really quickly. So that's kind of where we're at right now. So flipping, and I hope and I know that the community is going to start catching up, because right now, from what I'm reading in the ecosystem, is that a lot of people don't really understand why you need resources, prompts, or sampling, or anything else like that. But I think we can make an extremely strong case why this is important, and get people to start upgrading and getting out there, and we can raise that flag and help people there. But going over to the code, here we go. Share. A lot of this is in the orchestrator right now. So we got the tools, the planning and execution of tools. We have the resources. So it's able to forward information from other tools if it needs to show resources to the client. And same with prompts. It's able to forward that information from tools to the client. So the orchestrator is basically passing through a lot of information to enable this, but also it's able to do, of course, the orchestration itself with tool planning and the results, and what steps it took to be able to do it, how confident it was on the tool selection And if it's not really confident on the tool selection, it can go to the LLM and go basically, right, here's what I'm proposing. Does this look correct? And the LLM should be able to look at it and go, yeah, this makes sense. Let's run that. Or if the LLM's also unsure, it can ask the user as well, which is quite good. But the big one that I'm working on right now is elicitation. And elicitation is it's tricky, mostly because I haven't found a client that actually does elicitation. So I'm writing a bunch of tests to make sure that it actually works. But the other thing about elicitation as well is that since we have all these MCPs and they're being discovered from registries or in an MCP file or from other services, we don't want the clients to be blindly using everything because that's a huge security problem. So it is every single time that it proposes something, it's gonna check, for example, if it's actually allowed or not. So the first time that it uses a tool, it's gonna ask the client, do you want to allow it once? Do you want to allow it always? Do you want to deny it with a description? And we could also, or I mean, we also do include the provenance of like where this tool came from. So if it came from something they set in the MCP.json, then that's where it'll say that. If it came from like our trusted registry, which we believe is good, then it'll say it's from that. If it's from a different registry, it'll say that. But not only that, it'll forward over it'll forward over elicitation from tools as well if they need information. So there's a few things more that I need to hook up on this, but so far it's just about complete. And this is the big one that I wanted to include for us to go forward with this and then do a bit of cleanup. And I'm happy with the Orchestrator as it is now, because through my testing, it's working quite good. The tricky thing is finding a client that is actually able to do all of the things in the specification. But not only that, finding MCPs that have everything is defined for elicitation and everything else as well. But that's where I'm at right now. There's just a couple of things left to do in elicitation, namely me feeling confident that it is good to go and that I'm correctly implementing it. But other than that, Orchestrator is, for a first release, is just about done.